Hi class, we need to take a look at what type of integrals are going to show up in the partial fraction decomposition section. Now, some of the actual integrals may be from the review. I'll add these at the end of the lecture or in between. And then the rest of them are going to be of this actual form. So you're technically looking at a ratio. So they're all going to be fractions. And here, this portion is actually important. You want to make sure that, well, the degree of p of x is greater than or equal to the degree of q of x. And for messy fractions, in order to evaluate the integrals, we're going to basically, well, take a look at these formulas and see which ones actually apply. Some of these problems, though, are extremely long, so we would be using technology like the TI-83 to solve systems of equations that show up as we find the constants. Now, before we jump into the actual, like an actual problem, let's take a look at what happens in the process as your integrals become messy fractions. And this is example one. So one of the portion that could occur on example one is that you're looking at some fractions and the fractions had been actually expressed as single as a single fraction. So several steps might have been omitted. Now, this is the only thing they want for this problem, and they want us to simplify the fraction. Now, simplified means express it as a single fraction. So in this case, we would have done the LCD, and your LCD happens to be x plus 1 times x plus 3. And then this actual fraction, we're going to be actually rewriting it as, well, this is 3 over x plus 1 plus the values of 5 over x plus 3. And each of these, what we're going to do is multiply by a factor to obtain the LCD. So the first one is missing the x plus 3. And the second one is missing the x plus 1. So in this case, we're looking at 3. And let me rewrite them as an actual fraction. So this is 3 times x plus 3 over x plus 1 times x plus 3 plus 5 times x plus 1 over x plus 3 and technically x plus 1. Now, remember that the main idea when we're simplifying fractions, you're expressing them as a single one. So that's actually what causes the problem here. So in this case, we're going to have x plus 3 plus 5 times x plus 1 over the values of x plus 1 and x plus the values of 3. Our final solution will have the actual numerator completely simplified. In this case, you can actually distribute the 3 times those 2 and the 5 times those 2. So we're actually looking at 3x plus 9 plus 5x plus 5 all over the values of x plus 1 and x plus 3. So this fraction, we can actually express it as 8x plus 14 over the values of x plus 1 times x plus 3. Now, it's not actually needed, but let me actually factor the actual numerator. So in this case, you're going to have a 2 times x, this is supposed to be a 4x plus 7 over the x plus 1 times the x plus 3. And then all of these, remember that they have a disclaimer, x cannot equal to -1 and -3. These are the values where the functions are actually not defined. So if they just want us to express, or in this case, simplify the fraction, that's what you're looking at. Now, this is the idea behind the partial fraction decomposition. So you're going to have integrals that contain this fraction. And what we need to do is technically reverse the process to express them as the original one, meaning as the factors of two terms, in order to evaluate each of those actual, well, integrals.